Hi. Today we're going to work on infinite series and sequences, something like these over here, like a half plus a half squared and so on. And we're going to add them up forever. And we're going to generalize these, a over b plus a over b squared plus a over b to the third, and so on. These things they use in calculus, and it's important. And don't worry about making mistakes when you work on it. Have some fun. Try things different ways. You could get out some graph paper that looks like this. For the first problem is 8 by 8. We're going to do a half plus a quarter plus an eighth, and so on. And we're going to keep doing that forever. Now stop the videotape, and when we come back, you'll see a young person working on this problem. How old are you, Jane?
6.
6. And Jane is working on a half plus a quarter plus an eighth plus a 16th in infinite series. And people don't normally do that when they're 6 years old, but Jane has done it, and we're just showing you what she's done. The whole thing is 1, and the purple is
a half.
All right, and then this red part you've shaded in to be what?
A quarter.
That's a quarter. And now if we add a half and a quarter, what do we get if we add those two together?
3/4.
3/4. How did you know that? How do you know that, 3/4? Where did you get 3/4 from? How many fourths over here?
2.
2, and this one?
3.
So that's 3/4.
1, 2, 3.
Okay, so a half and a quarter is 3/4. All right. Now if we do a half and a quarter, you get another color, huh? Do you know what's going to come next?
An eighth.
An eighth, okay. Now what's an eighth? Where did you get an eighth from? Because it's what? How is that related to a quarter?
Because it's half of a quarter.
Right, half of a quarter. We're doing a half plus a half squared plus a half cubed. That's another way to say it. Could I recommend a darker color? The yellow doesn't show up as well, all right? Any other color would be all right. Okay, good. All right, now we're going to do an eighth, huh? Why don't you shade in 1/8 of the cake? Yeah, well, I'll hold it. Go ahead. And can I use your orange pen? Now, can you add up the half and a quarter and an eighth? How much is that? Okay.
A half plus a quarter plus an eighth.
What do you think? Look at the picture. We're going to add the purple and the red and the orange together, huh? And what is that all together? What's left over that's not shaded in?
An eighth.
An eighth. And how many eighths make the whole cake?
8.
8. So how many are shaded in?
7/8.
Right. Okay. Do you want to write that? 7/8? Why don't you write 7/8 there? Okay. All right. Now, what's the next piece that we're going to add on?
A 16th.
The 16th. Why don't you add on a 16th, huh?
Okay.
All right, looks like a 16th. And how did you get that as a 16th?
Because it's half of what I put in this first time.
Half of an eighth is a 16th. How do you know that? How do you know that? How old are you?
6.
6. My goodness. 6 years old and can do a half of an eighth as a 16th. Amazing. Now, if we add them all together, what do we get? A half and a quarter and an eighth. A half and a quarter and an eighth and a 16th. What do we get for that? What do you think?
Fifteen 16.
Say it louder.
15 16.
Sounds right to me. So we got the first one is a half, and then we added the next two, and we got 3/4, huh? And then we added the next one, and we got what?
8
7/8. And then what? 15 16ths. Now what's happening? If we keep going, if we keep adding them up, keep adding on pieces here, will we ever get to the whole square equal to 1? Will we ever fill the whole square?
No.
No, I guess you're right, huh? Will it get closer to filling the whole square? Will we get closer and closer to filling it, but never fill it? How come? Why won't we be able to fill it?
Because the pieces are getting smaller and smaller.
Yeah. And we never fill up the whole thing. No matter how long, if we keep doing it night and day for the next 100 years, will we ever fill up that square?
No.
But it's getting closer and closer to what number?
1 whole.
1. Thank you very much for coming. You did a great job here, and I appreciate it. Thanks. Well, you saw Jane, Andrew, doing a half plus a quarter plus an eighth and so on. And you notice she didn't make any mistakes. Now, what we're going to talk about for a second is making mistakes. It is well known that Newton and Leibniz and Euler, the really big mathematicians, made a lot of mistakes with these infinite series. And I'm going to show you a couple of mistakes, a few mistakes that people make, students make, children make, working on these. The first one I'll show you is in trying to show, like, if this is one cake and trying to show a fourth of it, they color in 4 squares. Now, the big question is, what does a fourth mean? A fourth means you're going to share it with 4 people. Now, if you take that section and make it 4 of them, you will not cover the whole cake. So you're not sharing, you're not showing a fourth because you're not sharing the whole cake with 4 people. Another common mistake, people say a half plus a quarter equals a sixth. You know and I know that a quarter of a dollar is less than half a dollar, or 1/2, I call it. And certainly if the bottom number is bigger, the top numbers being the same, the fraction is smaller. So if you have a 1/6 there, that's going to be smaller than a fourth. And you can't have a half plus a quarter, 2 bigger pieces equal to a smaller piece unless you're dealing with negative numbers, which we're not doing here. The other mistake Tova made the other day, she was doing a half of a half equals a quarter, and then she wrote a sixth of a sixth equals a 12th. And I suggested we made a 6 by 6, I made a 6 by 6 square for her. That's 1. I asked her to shade in 1/6 of it, which she was able to do. And now we're going to take a sixth of that sixth, and that becomes this piece over here. And the question then is, that's 1 piece out of how many? How many squares are in here? 36, so that is 1/36. So a sixth of a sixth is 1/36 and not 1/12. Now we're going to show you how some students do a half plus a quarter plus an eighth and so on different ways on the graph paper. This is Christine Kim, who's 9 years old. She made the picture of a half plus a quarter, and she went all the way up to 1/4096 and made it into this picture, put it in the picture, and she made the comment, if you add all the numbers above, you will get smaller than 1 and you won't get as big as 1. And I think the important thing also is that 1 is the smallest number that's too big. The next one was done by Titus, who cut the square down diagonally and did the half plus a quarter plus an eighth plus a 16th and got that far, which I thought was an interesting way to do it. This next one is Angela, who did it in vertical pieces, which is interesting. And the pieces are color-coded, and she has a half and a quarter. There's 3/4 here. And she also did a half and a quarter. The quarter is half of a half. So she also says that it's 1 1/2 halves. In the process, we also did a half of a half is a quarter, and a 16/16 is the whole cake, and 32/32 is the whole thing. And we're getting the partial sums here, a half, 3/4, 7/8, 15/16, 31/32, and so on. She goes up to 511, 512. And one of the big questions is there a pattern to this? And that's very important. And I think that she saw a pattern in these fractions, that the numerator was 1 less than the denominator all the time. I asked Angela to do a half plus a quarter another way, and this is most exciting. She did the cutting it diagonally like Titus did, but then she also tried to cut and make it a quarter diagonally also. Now, it turns out she did this picture first, and it turned out that this piece over here is really 3/8. We figured that out from the squares. And then she went back and tried it again, and it turns out that there are 14 squares in this light brown here. The whole thing is 64, so 14/64 is not equal to a quarter. It turns out that 16/64 is a quarter. So this was too big, and this part was too small, and she still hasn't gotten it. But I thought that was very exciting. Sarah, who was 7 years old, after we were working on a third of a third of a third and a third plus a ninth plus a 27th, said unsolicited, which I think is a very important idea that she had. At school, when we do math, we use different methods that I am not used to, and they are hard. But if I used my own methods, it would be easy. Now I'd like you to try a third plus a ninth plus a 27th plus an 81st and so on. And when you make the picture, I would recommend starting with a 9 by 9 square or a 27 by 27. It'll be easier to do the fractions and show them. And now you can stop the tape, and we'll see one of the students' works after this. This is Kirsten's picture of a third plus a ninth plus a 27th and so on, the infinite series. She shows here a third of the picture because she says there's 3 pieces there, and a ninth because there are 9 pieces there. And so, same thing for a 27th, which is a third of a ninth, and an 81st, which is a third of a 27th. She gets the partial sums. A third plus a ninth is 4/9 by saying this is third is 3/9 plus the 1/9 is 4/9. And a third plus a ninth plus a 27th, she adds on, she gets 4/9, which is 12/27 plus 1/27, which is 13/27. So she's getting the partial sums, 1/3, which is the beginning, 4/9, 13/27, 40/81. Lucas, who did this the other day, said that the 4/9, 4 1/2 is equal to a half, and 13 1/2 27ths is equal to a half, and 40 1/2 81st is a half. And Lucas, who is going into 7th grade, said that each of those fractions, the 40 81st, is a half of that 81st less than a half, which I thought was kind of interesting. Kirsten said if you keep adding the fractions, you're getting closer to a half. Now, of course, you're also getting closer to 1 and getting closer to 2, but it turns out that the smallest number you're getting close to is a half. And I think that's a key issue. All right, now you're going to try a fourth plus a fourth squared plus a fourth cubed and so on. And you'll stop the tape, and when we come back, we'll talk some more about that one. Well, you worked on a fourth plus a fourth squared. Let's look at what we've done so far. Working on a half plus a quarter plus an eighth. That infinite series goes to 1. A third plus a ninth plus a 27th. That goes to a half, if you do it forever, right? And a quarter plus a quarter squared plus a quarter cubed and so on. That goes to 1/3. Now, the idea, again, in mathematics is to look for patterns. Can you see a pattern here? Like, can you predict what 1/5 is going to go to? I'll bet you can. You're right. It's 1/4. Now, here's the big problem, okay? You can predict what's going to happen here. You probably can generalize on this. The next big problem to try is 2/5 plus 2/5 squared plus 2/5 cubed and so on. You might want to use a calculator. Stop your videotape now and try it out. Draw the picture. Use the calculator to add them up. And we'll be back to see how Jonathan, who's 7, has solved this problem. All right, the green part here is what, Jonathan?
2/5.
2/5 of this being 1 here, and the green part is 2/5. How do you know that's 2/5?
Well, because there are you can count 5 of these is this whole thing.
And that's 2 of them, so it's 2/5. You know, I think a lot of people worry about fractions, and it's so simple, isn't it? Not that hard. Okay. Now, the orange part is what, Jonathan?
4/25.
4/25, which we got from 2/5 squared, huh?
Yeah.
That's 4/25. So this plus this, did you get a number for that?
14/25.
14/20, because this is what, 10/25?
Yeah.
And 4/25 is 14/25.
14/25.
Okay. And this purple and blue part is what?
It's 125.
Okay.
125.
And that's got, you got that from 2/5 times 2/5 times 2/5, which is 2/5 cubed.
Yeah.
And that's 8 125ths.
Yeah.
And that's this in here. And you figured that out to be what? It was 14/25 plus what? Something else, huh? 825ths.
Yeah.
Okay. And then the last part, the red part, was
it was, let's see,
2/5 times 2/5 times 2/5 times 2/5, which is
16/625.
okay. Of course, 5 to the 4th power is 625. How old are you?
7 3
7 3/4.
3/4.
Okay. A lot of people don't believe that people 7 years old can do these fractions and the infinite series. Now, if you keep going forever on this thing, what's going to happen? Will it ever get to be the whole thing?
No.
What is it going towards?
2/3.
2/3. Now, you wrote a program on your calculator there,
Yeah, and it's, looks like I turned it off. There.
Or we wrote it together,
It went
huh?
off by itself.
It went off by itself, okay. What program are you in there?
Program 2. Oops, that.
You got to put, what, 2 in?
So we got to get rid of this.
Jonathan wrote, he and I wrote this program this morning, and he's going to put 2/5 in, and it's going to square it and then cube it and add them together and get the partial sums. And it gives you a decimal, right?
Yeah.
And if you keep going,
Yeah.
can you read off the decimals as you go?
It starts as 0.4.
Which is 2/5. All right.
Yeah.
And then 2/5.
It goes on to 5.560000. Then it goes on to 6.
Point.
Yeah, 0.62400.
Okay. 0.624, which already is getting close to. What's 2/3 as a decimal?
0.66666.
Now, how did you know that? Being only 7, how did you know that?
My mother told me.
Your mother told you.
Yeah.
And you said this morning, you said 1/3 you knew was what?
333.
0.333.
Yeah.
And so 2/3 is just
66666.
0.666.
And it goes on and on and on and on and on and
And if you keep going, it's approaching what?
0.66666.
Which is 2/3. All right, now what I'd like you to do is to try to generalize the a over b plus a over b squared plus a over b cubed plus ... from the work we've done before. Now stop the tape. When we come back, Jonathan and I will talk about the generalization. Now you said at one point if you do a over b plus a over b squared plus a over b cubed, that will go to what? As an infinite series goes to what?
A over b minus a.
A over b minus a, and a is 2 and b is 5, so it's 2 over 5 minus 2, which is 3, and so it's 2/3, and you're right, huh? Well, you've just seen some young people working on important mathematical ideas like infinite series and infinite sequences, using simple ideas of adding and fractions, and that was it. Important thing is that you can start early working on them, and the earlier you start, you make mistakes, and you don't have to worry about the mistakes, and everything will come out all right. Try to do things different ways, and very important, look for patterns in what you're doing, and most of all, have fun doing the math. See you.
This calculator goes all the way to 66. Well, it actually gets a 7 at the end.
Now, why does it have a 7 at the end?
Because it just rounds it off. It gets to 6666. And since it doesn't go, the numbers don't get any farther. It just goes to 7.
Rounds off.
Yeah.
Way to go.